Okay, so good morning, I'm Alex, a cloud engineer from OpenNebula, and I'm going to be the instructor today. So we are going to see an introductory tutorial on how to manage OpenNebula and how to create your own clouds. So in this tutorial, this is a beginner level session, so if you have tried OpenNebula before, this is very simple for you, but if you have never tried, this will be very helpful for you. You will see how to manage it, and then we are going to go through the process of installing, configuring, and use the OpenNebula in an enterprise level. And then we are going to learn how the cloud architecture, how can we install a general and technical configuration of OpenNebula. So these are the contents. We are going to start with the OpenNebula packages, how to install it, how to manage them. Then we are going to see what is a host in OpenNebula, how we can manage it. Then what is a data store in OpenNebula, what type of storage drivers we support. Then we are going to see the virtual network, again, what type of drivers do we have. Then what is a VM template, how can we create it, install it, instantiate it, and all these things. And then a very important part in OpenNebula, which is the user management part. And finally, the different sandstone views. So after the tutorial, you are going to be able to describe the future and benefits of virtualization and cloud. You can describe the different architecture of a cloud that can be deployed with OpenNebula. You will be able to install it, and then the basic configuration of the cloud. This is the agenda. We are going to start at 10:30 to 20:12. Then we will have a little break, and we will finally until 1:30. Here you have all the material for the course. You have the connection details for the virtual labs we are going to use, and this presentation and the other presentation in PDF format. So you can access there and take a look. Does everybody has the URL? Okay, so we are going to start with the tutorial. So first of all, these are the contents. We are going to start with the architecture, then I'm going to explain you how to connect to the virtual lab, what you have in the virtual lab. Then we are going to see the OpenNebula interfaces, mainly Sandstone and the CLI. Then hosts, data stores, virtual network and templates. And finally, users and groups management. So this is an overview of what is installed in the virtual lab and a typical OpenNebula environment. We have 3 nodes. The first node is the frontend, when the 1G daemon is installed on it, and we have all the drivers to manage storage, network, etc. Then we have 2 hypervisors. These are the worker nodes. The frontend will connect them through SSH and will use them to run in the VMs on the cloud. So this can be KVM node, LXD node in the new OpenNebula version, EC2 node, or if we use disaggregated data centers, we can have a node in a bare metal provider. And then we have the data stores, which are the storage for OpenNebula. There we have the repository of all the images, files, etc. So we support multiple type of backends, Ceph, LFVM, etc. Okay, so now we are going to see the virtual lab. In the virtual lab, we have the three nodes, the Frontend, which is node 1, and the two hypervisors, which are node 2 and node 3. In the Frontend, it is called OpenNebula, Samsung, etc. And there is an FSR server to the storage, which is shared between all the three nodes. In the two nodes, we have the NFS client, we have KVM and Litbird installed on it, and we have a bridge, which is VR0 configured in order to the VMs has private communication between them. And then we have the data stores to store image and running VMs. So now you can try to SSH to the virtual lab. There are 14 virtual labs. I think you can do it in pairs, or if you are alone, you can use your own. So here, where the X number, you can use from 1 to 14. The 15 is mine. So you have to SSH to the IP, which is in the connection details. The user is gateway, and this is the password. And then when you are in Gateway there is a big OpenNebula installed on it. You have to SSH to your own lab. So when you are in Gateway, you just SSH to your lab number. And remember, the node 1 is the OpenNebula frontend. So try it, and if you have any doubts, just raise your hand and I will help you. Maybe I can put the connection details. Okay, so this is the IP. Oh, nice, thank you. This is the IP, and here you have the command. And then please SSH to your lab. So start from 1, then 2, 3. Remember, the 15 is mine, so I will do the course here. And if you are using Windows, then I have the instructions to connect using PUTTY. So I will give you a couple of minutes. Okay, so are you in? Do you have any problems? Okay. Is anyone using Windows? Okay. Do you need instruction for PUGTY or you have? Ah, okay. Okay, so we are going to continue. Sorry, instruction. So this is in the virtual lab. All the root password for all the node is OpenNebula. There is a OpenNebula 5.61 installed on it. To use OpenNebula, we will always use the OneAdmin account. So you just switch to that account in the frontend to use it. Both nodes are registered and all the stuff to KVM is installed on it. And Sandstone will be available on your laptop at localhost 9869 because we have forward the port in the SSH command. And the login is OneAdmin and OpenNebula is the password. Remember to keep your SSH connection always open because if you close it, you won't be able to access Sandstone in your web browser. So now, if we are in the node 1, we can SSH to both nodes. So to node 2, the password is OpenNebula. You can see we are in the node, and we can do the same to the node 3. Again, the password is OpenNebula, and we are here. Okay, so remember, node 2 and node 3 are the KVM hypervisors. First of all, we are going to do some on hands-on. I will do it myself, and you can follow me. The first thing we are going to see is what OpenNebula packages are installed on the frontend. These packages has been already installed by us, and we can see them with that command. This is a CentOS, so and here you can see these are the packages that we have installed. The first one is the flow, which is a component that allows us to communicate from VMs, from inside the VM with OpenNebula. Then we have the common packages with some extra things. Then the OpenNebula and OpenNebula server, which are the daemon that controls everything in OpenNebula. And then we have the Sandstone and Ruby, which are all the things that Sandstone needs to run. Okay, and now we can SSH to a node, and we can see that there are different packages. So in this case, we have the common again, and then we have the node KVM, which has all the stuff to manage a KVM host in OpenNebula. And now we are going to see the services that are running in the frontend. Okay, so we can use the command systemctl. As you can see, we have the flow service running and the gate. Gate and flow usually go together. Then the node VNC, which is the VNC client we use to connect to the virtual machines from Sandstone. Then the scheduler. The scheduler is a separate process from the 1D and is in charge to deploy the VMs in the host using different scheduler policies. Then the Sandstone service, which is the web browser to use OpenNebula. And then the OpenNebula server, which is the the daemon that control OpenNebula. And if we SSH to the node 2 and node 3, we are not going to see anything about OpenNebula because the service running there is the Kemu and Litbird to virtualize all the machines. And now we are going to check the storage. As I said before, we are using NFS server. So in the node, we can check that we are exporting the directory HRV, and then we can check that the 3 data stores in OpenNebula, which are located in var lib 1 data stores, are pointing to the NFS server we are exporting. So we have the data store 0. We are going to see later what is this data store, the data store 1, and the data store 2. In the worker node, in the hypervisor, we have configured the NFS client 2 in order to access to all the images. Okay, and now we are going to see how we have configured the network in the worker node. So we SSH to a node. And with the command vrctl, you can see that there is a bridge vr0, which is connected to the physical interface. In my case, you can see 2 running VMs because I have already done the course yesterday. But this is connected to the physical interface of the host in order to the VMs that are deployed in this host can communicate each other. Okay. And now we are going to check that we can SSH passwordless from the frontend to each node. This is this is compulsory in OpenNebula because the frontend will use OneAdmin account to communicate with the worker node. So this communication has to be passwordless in order to launch the VMs. So if you go to the frontend and we switch to OneAdmin account, now we are in OneAdmin account. We can SSH to each node with our password, as you can see. So we have configured SSH keys in order to do this. So OpenNebula can SSH to it. And then we are going to see some configuration that we have made in order to make the course better and faster. This configuration have already been done by us, so you don't have to do it. First thing, we have changed the database backend. OpenNebula supports SQLite and MySQL. So we have put a MySQL server. So we have changed the credential and user. All these changes are in the 1dconf, which is the main configuration file for OpenNebula. There you define the drivers, the MySQL database, etc. Then we have changed the schedconf, which is the configuration file for the scheduler. And we have changed the sketch interval. We have downgraded from 30 to 5 in order to the VM deploy faster than in a production environment, which you should have the 30 or maybe higher. Then we have made some changes in the KVM configuration. Basically, we have changed the cache of the. And then we have changed the OneGate server because the OneGate server is in the front end. We have put the IP of the front end, which is this private IP. And then we are going to see the OneAuth. This file is very important because the first time we launch OpenNebula, the daemon will read the password, install it on it, and will create the user OneAdmin with this password. So this file is located in the OneAdmin homes, which is barleaf 1. So you can see we are in barleaf 1, and then if we enter to the .1, we see the OneAuth here, and all the files that OpenNebula used to authenticate. So the OneAuth, if we cut, has the user and then the password. And then another important file here is the OneKey, which is the secret key that OpenNebula will use to encrypt all the secrets in the cloud. Okay. And now we are going to see a summary. So remember, to install the repos, we have to configure the OpenNebula repo to point to our repos. Then we can install all the packages using the command. OpenNebula is the daemon, and then OpenNebula -Sandstone, OpenNebula -OneGate, OpenNebula Ruby, etc., and it will install all the things. Then we have to run the install gem script. This is located in user share 1, and it will install all the Ruby dependencies that OpenNebula needs. Then we enable the services and start them as we saw before. Then we configure the storage. In our case is NFS, but we can use another type of storage. Then the network. We are using bridge networking, but we support another types of network, and you can create your own network. I will tell later how to create your own drivers and everything. Then we have to configure the passwordless SSH between the node and the frontends, and then we can modify and tune the configuration files as we want. All the configuration files are located in etc1, and there you have all the files. So first of all, we are going to start with the OpenNebula interfaces. Mainly, there are two interfaces, the Sandstone and the CLI. So first of all, we are going to overview the CLI. Remember, all these commands has to be done under OneAdmin account, because OneAdmin is the most important user in OpenNebula. All the things are running under this user. So if we go to the front end, remember you have to be in the front end. These commands are not installed in the worker nodes. You can see all the commands in OpenNebula. They have the same structure. All of them start with 1, followed by the resource we are going to use, ACCT, ACL. Okay, so we are going to review one by one each of them. The one user command is the command to manage users, so we can create users, change the password of a user. So in each command, if you use the option H, you will see the help. So for example, in one user, we have the create command, where we can create a new user. We can see here you can see examples, because each user we can create with different type of authentication. By default is a server authentication. It just make a SHA of the password and nothing else. Then we can update the user. Oops. We can update the user. It will prompt an editor, Vim, Nano, whatever you use, and you can change the content of the templates. These two subcommands are available in most of all the commands in OpenNebula, because you can create and update everything, data store, virtual network, etc. And then you have specifics commands for the users. For example, we have the quota, so we can define some quota limit for each user. We have the Umax to change the Umax for default permissions. We can create login keys. We can change the password with command passwd, the same as Unix system, etc. Then we have the one group command, which is the same as user but for group. We can have several groups in OpenNebula, and each user can be in any group. By default, there are two groups created: the OneAdmin group, which is the group for OneAdmin and server admin. Server admin is the user that Sandstone use. And then the users group, which is the default group for any new users. Then we have the OneACL command. This is for manage ACL. The ACL is the same as its Unix system. You can create rules to define what resources are available for each user or each group. Then we have some command to manage resources in OpenNebula: one host to manage the virtualization host, one cluster to manage cluster. A cluster is a group of virtual resources in OpenNebula, so a cluster can have data store, virtual network, and host. Then we have the one data store, one VNet command to manage data store and VNet. The showback to have obtain a showback of the uses of the cloud. One VDC. VDC is a virtual data center, so you can group resources and users, and each user can have only access to that resources. So you can have VDC private, VDC public, VDC infra, etc. So it's very powerful to grab all your resources, virtual resources. One vCenter, which is the command to manage vCenter resources, to import new import appliance, etc. One zone. In OpenNebula we can have many zones, so with one zone we can change from one zone to another, create a new zone, etc. Then one image to manage image. Images are the resources that has the operative system of the virtual machines, etc. One template to manage templates. Templates are very important in OpenNebula because allow you to define what the virtual machine will have, what networks, what disks, etc. One VM to manage all the VMs. Accounting to check again the usage of the cloud. One market. There are marketplaces in OpenNebula where you can download images and templates. So with one market you can control it, create new one, update it. One DB, which is a tool for operate directly with the database. So you can modify the body of the resources in OpenNebula. You can upgrade the database from one version to another, and you can run the fsck command to check the consistency of the file system. And then the one flow, which allows you to manage all the flow, to start the server, to stop it, etc. One market app, which is related with one market, allows you to manage the app inside the market, to create a new app, to update an existing one, etc. And then the one vRouter to manage virtual routers, and security groups, which are firewall rules to allow traffic. And in the new version of OpenNebula, there are two new commands: the one provision that I will show you later, and the one VNet template, which is the same for templates but virtual network template. So allow you to create virtual network templates, and the users can use these templates. And then Sandstone. Sandstone is the graphical user interface. You have it in localhost 9869, and this is Sandstone. This is the dashboard in OneAdmin account. So here you can see all the resources in the system, and then here you can manage everything. So in instances, you have your running instances, VMs, virtual routers, And in templates, you have all the things to virtual routers template and virtual machines templates. In storage, you can manage the data store, your image, your files. Network, you can manage the networks. Infrastructure, here you have clusters, hosts, and zones. Then in systems, you manage all the things related with users, groups, etc. And settings is a normal settings. So we have different views in Sandstone. There are views for KVM, views for vCenter, and a mixed view. So views for KVM only have the things to manage KVM cloud, vCenter for vCenter, and mix for both. And then inside each of them, we have the admin view, which is the OneAdmin view. Then we have the group admin view. We can switch, oops. We can switch to it. And as you can see, here there are less things than in the other view because the group admin user will manage the group. So it doesn't need to know anything about the infrastructure or the network or the data store. It just need system to manage users and groups, template, and instances. And then we have the cloud view user, cloud view, oops. This is the view that end users see. So as you can see, there are less things than in the other two. There are just VMs tab. You can see here the VMs that the user have. Templates, you can see the templates. You can instantiate them there here. You can use it, you can customize it. And then services. In this case, we don't have any services. A service is a group of virtual machines that work together. For example, you can have a service that is a Kubernetes cluster, or a service with 3 VMs. One is a database, one is a host, or whatever you want. So to manage this, you use the OneFlow and the OneGate. And now we are going to start with host. Remember, a host is a place where we virtualize the machines. So it can be a KVM in the new version and LXD, and public cloud provider, EC2 and Azure. So the first hands-on you have to do is to create two hosts. So create one using Sandstone, and then create another using the CLI. So remember, you have to use the index, the number of your lab, and you have the node 2 and node 3. So add both of them, one using Sandstone, and the second one using the CLI. So in the CLI, you use the command create, and then the information driver, which is the driver that will collect all the information from the host, the CPU, the memory, etc. And the virtualization driver, which is the driver in charge of deploy the VM, shut down the VM, etc. So then you have the command list on top, which will list the host available. So create the node 3 with CLI, and wait until they are in on state. So I will give you 5 minutes to do this. And if you have any doubts, just ask me. I will continue. You should have two hosts in on state. So with the command show, we can see the details of the host. We can see the ID, which is a unique ID that OpenNebula uses to manage the resource. The name, the cluster, each resource is automatically added to the default cluster. So if we want to create a new one, we can create new cluster and move the host to one cluster to another. Then we can see the information and virtualized driver. And here we can see the memory that is available and its use, the CPU, and here is the monitoring information. So these are the key value things. As you can see, the CPU model, the hypervisor, etc. Some of these things come from the image information driver, which is located in the directory /lib1 remotes. Here you can, oops, it's really bad. In here you have the drivers, the data store drivers, etc. And then we can go to IM, which are the information drivers. And then we have the information driver for all the hosts that we support. Azure, EC2, KVM, vCenter. So if we go to VM proofs, these files are shell scripts that execute in the host and return the information to the frontend. So for example, if we open one of them, you are going to see that is a simple bash script. At the end, it returns a key value. So you can create your own scripts and share them to the host, and OpenNebula will collect that information. To create your own script, you just have to create a new file here. It has to be an executable file. Then you have to use the command onehostsync. This command will copy all these scripts to all the hosts in OpenNebula. And then you have to wait until OpenNebula monitor the host, and you will see the new information in the template. If you don't change this, here you have a file version. This is the version of the scripts. So if you don't change this file, anything will be updated because OpenNebula assumes that you haven't changed anything. But if you modify this file, so maybe we could put a new version. Now OpenNebula will update the two nodes. So if you change, you create a new file there, you change the version, and OpenNebula will update them. If you don't want to change the version, you can use the option false, and it will update them anyways. Okay? So we are going to continue, and now we are going to see the data stores. Remember, the data stores are the storage for OpenNebula. So in OpenNebula, we have 3 data stores. And you can create your own data stores. The data store 0 is a system data store. In system data store is where the running VMs are stored. So imagine you have a running VM, that VM has an image. So that image is copied to the system data store where the VM is running. Then we have the image data store. This is the data store where all images are stored. And then the file data store. You can upload your own files to your cloud to use them whenever you want. So there is a hands-on here. You are going to create an image. So you have to go to Samsung, to the storage tab, and then click on images. And you click on the add button. So you put the name Ubuntu 16.04. This is the path of the file, and then in advanced options you put the bus Bartayo, and the mapping driver cookout2 because it's a cookout2 image. So you click on create and you have to wait until the image is ready. So I will give you a couple of minutes and you can do it. If you prefer, you can do it by using the CLI, using the command create. So you go here, storage, images, and you click on the plus button. I have mine already created, so I will give you a couple of minutes. Okay, so here you can see the information of the image. Again, the ID, the name, the data store is the default data store, which is the default image data store for OpenNebula. And then here you can see the permissions. In your case, you will only have the first two, use and manage on owner. We are going to change this later. And then we can see here some of the attributes on the image. Then we have VM tabs. Here you have all the VMs that are using that image. In your case, you won't have anything. And then the snapshots. If you create a snapshot of this image, you will see it here. Okay. So now we are going to change the TMMAT, which is the transfer manager driver. This driver is used for transfer the image from one data store to another. So when we instantiate a VM, the image is copied from the image data store to the system data store. So there are several TM drivers. I will show you where you can configure them. This is in the etc1.1dconf. Remember, this is the configuration file for OpenNebula. And if you search TMMAT, you are going to see all the transfer managers that we support by default. So as you can see here, these are all of them. And you can create your own driver. You just have to put a comma and the name of your driver. And then you need to put the configuration of the driver. Okay? And when you have done this, you go to the remotes folder. You go to data stores. Oops. And you have to create your own, no, wait. Okay, you go to TM, sorry. TM, and here you create your own folder with all the scripts that OpenNebula needs. For example, if we enter to cookout2, you see that there are scripts to clone an image, to create a snapshot of the image, to monitor, etc. So if you want to create your own TMMAT driver, you just have to implement all these things, and OpenNebula will call your script each time it needs. So now you have to change the TMMAT in the default and system data stores. Okay, so you go to the data store tab, you click on Systems, and on the bottom, you have the TMAT. In my case, I have already changed it. So you will have a share. So please change it from share to cookout2, the system and the default. You can do it using the CLI. So one data store, update 0. It will prompt a Vim editor, so you just have to edit this and put a cookout2 in the system and in the default. Okay, so okay, and now we are going to start with virtual networks. Okay, first you are going to do a hands-on. You are going to create your own virtual network. So remember, as we said before, in each hypervisor we have the bridge VR0 configure. So you are going to create a bridge networking in order to the VMs can communicate each other. So these are the things that you have to put. First, you put the name, which is private. Then, as is a bridge network, you have to specify the bridge, the name of the bridge. Then you specify all the addresses. So we are going to start at this address, and the size will be 100. And then in the context, you put the gateway and the DNS. So you can do it by the CLI, but we will never use the CLI to create network because it's more complex than in Sandstone, because you have to specify all these things in a configuration file and then create the network. So for create networks, it's better to use Sandstone. So you go to network, you click on create. So first of all, the name, description if you want, and then the cluster. We only have one cluster, so we can select anything else. Then the bridge. These are the types of networks driver that we support. You can use your own, again, and as we did with data stores, you create all the files that OpenNebula needs, then you activate it in the 1D-conf. And remember, every time you change anything in the 1D-conf, you have to restart the service. So the change is applied. Then we have the addresses. You can have IPv4, IPv6, or Ethernet address range. Then the security. These are the security groups. When you create a virtual network, by default, it is added to the default security group. The default security group allows all the traffic. So if you want to create a security group, remember to remove the network from the default security group. And then we have the context section. Here you can put the address, the gateway, etc. All these things will used by the contextualization packages to configure the network inside the VM. We are going to see this later. So create the virtual network. I will give you a couple of minutes. I have already created, so this is the network. Okay, so here again you can see all the things related with the virtual network and at the bottom you can see the attributes. You can create new key value attributes, and here you can see the address ranges. A virtual network can have multiple address ranges. Each address range can be for a different type. So you can have a virtual network with IPv4 and IPv6 range. Here you have the leases. In your case, it will be empty. These are the addresses that the current VMs are using. Here you have the security groups. We have the default. Here you will see virtual routers in case you are using one of them. And here the clusters. So anything else? Now we are going to see the virtual machines, which is an important part, obviously, in OpenNebula. So first of all, you are going to create a virtual machine template. The template can be created directly by you, or you can download it from the marketplace. We have one marketplace, and in the marketplace you have a predefined apps by us. I will show you. If you go to Storage tab, and you go to App, here you can see all the apps that we have in the OpenNebula public marketplace. And in the new version, we have another marketplace, which is the LXD marketplace, where you can download LXD containers template to use them with OpenNebula. So, for example, if you click on one app, here you can see the template. So this is a template for a VM in OpenNebula. You can see some app things like the driver, etc. Then the context. This context is the section that will be used by the contextualization scripts. And then another things. So you can download the app to your cloud, this button, and you can download the image to your cloud. But at this time, you are going to create your own template. So to create the template, you go to template section. There are templates for VMs. You are going to create one now. There are templates for services, for virtual routers, and the VM group, which is a way to group VMs and set rules of affinity and anti-affinity. So if you go to VMs template, you click on the new button, you have all the things that you can configure. So you are going to put a name, choose a logo, a description, the CPU and the memory. Remember, the memory has to be in megabytes. By default is in gigabytes, so change it because we don't have 512 gigabytes of RAM. So then the storage, you create the image, you click on the image you created before. Then network, again, the network you created before. And in input, if you have another keyboard layout, you can specify it here to use the VNC client. There are another important things here, but we are not going to use it now. I will tell you. There are the actions. These are the schedule actions. So you can schedule some actions in the VMs. So this is very powerful. Imagine you want to take a snapshot every day. So you can use a periodic schedule action, and each day OpenNebula will take a snapshot of this VM, or power off, or reboot, etc. Then the context. Let me. In the context, you have to click on Add OneGate token. The OneGate token is the token that OpenNebula used to communicate to the OneFlow server. And you click on Report Ready to OneGate. This thing will do when the VM is ready. The VM will tell OneGate, okay, I'm ready. So you can use it wherever you want. And then SSH key. If you add your SSH, you will be able to SSH to that VM passwordless, because contextualization scripts will configure the authority keys for you. So you also have to let it check it. And then this is the start script. The start script is a script that is executed every time the VM boot. So here you can put anything you want. Imagine you every time you start a VM, you want to send an email to anyone, you want to create a directory, etc. So you put it there, whatever you want. In our case, we are going to put this start script. And then we have the custom bars. These variables are used by the contextualization scripts again. So in our case, we are going to put the key password and the value OpenNebula. This will make that the root account password will be OpenNebula. So it will configure automatically. And finally, you are going to add the SSH key to your account. So you have to take your public SSH key from the frontend, remember. Then you go to the user settings here. And you go to the auth path. So here you click on the edit button, you paste your SSH key, and when you finish, you click out of the box, and it will configure the SSH key. So this SSH key will be copied to the VM when the VM is instantiated, and we are going to be able to SSH to that VM without password. Okay, so I will give you a couple of minutes to create the template. Remember, first these things, then the context section, and finally add your SSH key. Okay, so if you have any doubts, just raise your hands and I will help you. Okay, so when you finish, you will have your VM template, and this is how it looks like. The context section, network equals yes mean that the contextualization script will configure all the network inside the VM. Then you have the password, the report, your SSH, etc. Then we have the CPU, the DIX, which is the image we created before, graphics. In my case, I put the Spanish keyboard map. And then you have the memory, and here you can see the NIC. So we are going to use the private NIC and the security group 0, which is the default. So now it's time to instantiate it. So you are going to instantiate 2 VMs. So to instantiate a VM, you just click on the instantiate button, and you select 2 instances. The name, you can leave it blank. If you put some name, you can, but if you leave it blank, OpenNebula will generate a name for you. And then you go to the instances tab, and you wait until the VM is running. So the first state will be pending. In pending state, virtual machines are waiting for the scheduler to deploy them to a host. Then it will go to the boot state when the VM is booting up, and finally to running. Then you are going to see that each VM is deployed in a different host. We have 2 hosts, so VM1 is going to be in host 2, for example, and the other in host 3. And then you can check the VNC connection, okay? So remember, we changed the root account password, and now the password is OpenNebula. You can check the configuration of the network with the command IP. You can pin the other machine because we have configured a private networking. And then the 2 last, we are going to do it together, so you can see the difference between a migrate and a live migrate. Okay, so I will give you a couple of minutes to deploy them, and you will be able to see the VMs here in instances, VMs tab. You have to see running here. And also you can use the CLI. So the command 1VM list will show the running VMs, and you can use the top, so it will continue refresh the CLI. So I will give you a couple of minutes to deploy and see, and then we do it together. Okay, so we are going to check the PNC and the migration things. So if you go to the running instances, you can click on one of them and then click on VNC button, and you are going to see the VM. So use the password OpenNebula, and if we type IP, we can see that we have the ETH0 interface configured. We have the IP, in this case is the 100, which is the first IP of the address range. And we can check that we can ping to the other VM. You can see, now we are pinging to the other VM. Now we are going to see the two types of migration. So let's leave it here. We have the cold migration and the live migration. So we are going to see the difference. If we make a first of all, we have to see where is the VM running. In this case, this VM is running in node 3. You can see it here in the host. So we are going to migrate the VM to the host 2. So we click on migrate. Remember, it's a call migration, and we choose the node 2. So we migrate. Now, see, the ping has stopped because now OpenNebula is making a copy of the current state and is copying that image to the new host. So this is why the ping has stopped and we have lost the connection. And now, if the VM is still in safe state, so it's saving all the stuff. Now it's booting on node 2. Remember, it was running on node 3 previously. So now it's running. So if we go to the VNC, see, the ping has continued where we left it. Okay, this is a call migration. Now we are going to leave the ping again, and we are going to make a live migration. So now it's in host 2. We come back to host 3, and we watch the ping. As you can see, the ping doesn't stop, just there is a high ping there. In this instance is when OpenNebula make the migration. This is a live migration, so OpenNebula copy the image to the new host without with the VM running. So this is why the ping doesn't stop, and you just see a high ping because of the copy of the image from one host to another. And now we are going to check the SSH connection. As we configure the SSH public key, we can, from the frontend, we can SSH to the root account. Oops, sorry, thank you. And as you can see, we are inside the VM. So this is because we have configured the authority key. So as you can see, here is the public SSH key of OneAdmin account in the frontend. And now we can check it, the contextualization scripts. So I will make it bigger. So if we log into the VM in this directory, you can see all the context variables that came from the VM. So these context variables are, if we make a one VM, so 0. Oops. This section, this whole section, is copied to the VM. So if you log into the VM and you go to that directory, and you. Here you can see all the variables are the same that in the context. In this case, all of these are exported, so the contextualization script can use them. We have contextualization script for Linux and for Windows. You can find them in our GitHub. And these scripts are located in that root, etc one context. So these are the scripts. There are scripts to configure the network, to configure the username and password. This is for the password custom bar we used before, to configure the stage public key, etc. If you open one of them, for example, the network, as you can see, this is a normal bash script. So we configure the network using the configuration files, as you can see here. We generate all the configuration files in the VM, and this script contextualization are executed every time the VM boot. So when we instantiate a new VM, are executed. When we reboot it, are executed, and when we attach a new NIC or a new DIX. If we attach a new NIC, this script will be launched, and will configure the new NIC. Okay. And finally, we can check that our start script was executed. So if we go to TMP directory, and you can see that here is the file that we've created with that script. So we can put there whatever you want. This has to be executable in the VM, and that's all. Okay, now we are going to check all the actions we can do with a VM. The actions are located here on top of the VM. So we can suspend a VM or stop a VM. If we suspend the VM, the state will be safe and the VM will be in the host. If we stop the VM will be safe again, but it will take to the system data store out of the host. Then we can, here we have the power off things. You can power off a VM. You will shut down the VM and leave it on the host. And you can power off hard. So it will power off the VM without waiting to anything. And you can undeploy the VM. If you undeploy the VM will be powered off, and then it will be taken out of the host. And the undeployed hard is the same on power off hard. It will wait until anything. And then we have the reboot. Reboot will be just reboot the VM, and reboot hard will reset the VM. We'll reboot it and everything. And then you can lock or unlock the VM. If you lock it, you can do any change on it, and if you unlock it, you can do it again. And then you have the resume and save button. They are disabled now because the VM is running. If you power it off, there will be enable. And now I will show you the recover, which is here. This function is very useful. There are several commands to the recover action. Retry will retry the last action that was executed in the VM. So imagine the VM failed to go to running for anything. You fix the error, and you want to retry the boot. So you click on retry, and OpenNebula will retry the last action. If you fix everything, it will go to running. Then success. Imagine something fails, but you really see that it doesn't fail. So you tell OpenNebula, okay, the last action was success, and OpenNebula will assume that it was success. Failure, the same, but for for fail state. If OpenNebula tells you that everything is okay, but you see that there is something wrong, you can click on failure. And then the delete and delete recreate. Imagine you click on shut down, on terminate, and the VM doesn't terminate for anything, you can delete it. But remember, if you click terminate, the VM will still in the OpenNebula database. If you click on delete, the VM will be removed from anywhere. So take care of that. And delete recreate will delete the VM and create another one exactly the same as the previous one. So these are very powerful commands. And finally, you have the terminate. So terminate will power off the VM and remove it from the host, but will leave the information of the VM in the database. And the same for terminate hard. It will terminate the VM without waiting to anything. Okay, so we are going to make a hands-on. We can attach to the VM networks and DIGs. So in this case, we are going to attach a new DIGs. So first of all, you have to create a data block. Data blocks are like a generic storage. So you can create an empty data block in this case with a 100 megabyte size. And then you are going to attach it to the VM. Okay, so if you go to the storage tab, here you can see that you can attach a new DIGs. So when you create the data block, you are going to see the data block here, and you click it on it, and it will be attached to the VM. Then you go to the VM via SSH or VNC, and you check the fdigs command, and you are going to see the new device available. Okay, so I'm going to give you a couple of minutes to create the image. Remember, go to storage, then image, and click here. You can create different types of images. You can create an operating system image, a read-only CD-ROM, and now the storage and data block we want to create. Here you can see the image data store you have available. In our case, we just have one, the default data store. And then if we choose, and here you can tell the location of the image. You can choose a path in your OpenNebula server as you did before with the Ubuntu image. You can upload it one from your laptop, or in this case, you are going to create an empty image. So you put here the size. Remember, the size in megabytes. We don't have 100 gigabytes in the host, in the data store. And here you have the advanced options. The bus, in our case, we are going to use it virtual. And the image mapping driver, in our case, we are going to leave it as Cuckoo2. So I will give you a couple of minutes to create the data block and attach it to the VM, and then check it that it was successfully attached. Yes, at 12:20. Yeah, in half an hour. Okay, so now in the storage tab, you can see that the new disk is here. You can also check it with, oops, with the CLI. You make a show of the VM and you go up. Oh, it doesn't appear here, I don't know why. But you can use the XML format. So here you can see the object as is stored in the database. And here you can see the two disks. The first one is the disk with the image, and the second one is the disk we created before. This output is very useful because here you can see anything about the resource. If you use just the normal show, you will see less information than here. And the XML format output is available in every resource in OpenNebula. So every command has this. And if you use the list command, there is also a XML format. It will show you all the pool, in this case the VM pool, so all the VMs here. And also you have another format, which is CSV. Oh wow, oops, sorry. It will output the all the pool in the CSV format. This is helpful if you want to parse it with another external program or whatever you want. Okay, so now we are going to check that the data block is really attached. So we go to oh fuck. Okay, so as you can see here, we should have. I don't see it. I can see it. Maybe I choose the wrong VM. Let me check it. VM0. I don't see it. This is the SOS image, but I can see it the other. Maybe we can use another one with LSVLK. You can see that here is the disk with just attached, and here you can see the name. This name is the same as this, so this is the target, and will be the same here and inside the VM. And with these images, you can make some actions. You can save the. You can make a disk save as. Okay. You can make a snapshot of the disk. So you can make a disk snapshot, and you can detach the disk. So if you click here, it will detach the data block. And now if we refresh it, and as you can see, the data block is gone, and you can see the Ubuntu image we created before and the context CD-ROM with all the information about the contextualization. Now if we make this command again, you can see there is no data block. Okay. So now we are going to make another hands-on. We are going to check the capacity and snapshot. So first of all, the capacity. You can resize the capacity of the VM. So you can change the memory and increase it or make it lower. So if you go to capacity, you have the resize button here. Obviously, because the VM is running, you can click on it, because you can resize the memory when the VM is running. So we are going to power it off, And when the VM is in power off state, you can see the resize button is available. So you have to increase the memory. You can also change the CPU, but in this case with memory is just enough. And then when you change this, you power on the VM again with the resume button, and you see that the memory is now 768 megabytes. And now you are going to take a snapshot. There are two types of snapshot, the system and the disk snapshot. The system snapshot will save the whole system state. So the disk, the state of the VM in this case, etc. And then there is the disk snapshot. This will save only the disk state, not anything more. So you are going to take a snapshot. You are going to modify the VM, for example, make a touch of a file, and then you are going to revert to the snapshot, and you are going to see that the file isn't there. So I will give you a couple of minutes to do this, and then we are going to do it together, the resize and the snapshot. Okay, so we are going to resize the capacity to 768 megabytes. So now the memory has changed, and we power on the VM again. Have to wait until it boots. Oh fuck. Okay, the VM is booting up. Oh my god, it's too slowly. Okay. Now now if we use the command free, you can see that we have 700 megabytes of RAM. So now we are going to take the snapshot. So for example, we are in root directory. We are going to first we are going to take the snapshot. So we go to the VMs tab. We go to a snapshot. So we are going to take a snapshot. Test. We take the snapshot. So the VM now OpenNebula is taking the snapshot, and here we have the snapshot. We can revert the snapshot and delete the snapshot. Now we are going to modify the file system of the VM. So we are going to create a new file, call it test in the root directory. And now we are going to revert to the previous state. So we revert. Now Nebula is reverting the snapshot. So we wait. Okay, it's running. My god, again this. Okay, let me state again. And as you can see, there is no file there because we revert to the previous snapshot. So the snapshots are very powerful. Remember that there are two types, the system and the disk snapshot. The disk snapshot is made here. This is a disk snapshot. And create a new one if you want. And in Cookout 2, this is in a tree structure. So if you create a new one, okay, we can create a snapshot because the VM is running, as you can see here in the log. We have to stop the VM and then take the snapshot. Okay, and this tab is very useful, the log tab. Here you can see all the log of the VM. Okay, so if you have any problem with the VM, here you can see all the actions, the success action and the failing actions. And this log is also located in the frontend. If you go to bar log 1, here you can see the 1D log, which is the general log for OpenNebula. And for each VM, you will have a log file with the ID of the VM and then .log. So if you check one of them, here is the log of the VM. This is the same as we can see here. And then we have the 1D log. This is the log of OpenNebula. You can see everything that OpenNebula is doing, all the monitorization, all the actions, everything. So if you have any problem with OpenNebula, you can check it to debug it. And also there are another log file that are important, which are the sched log. This is the log for the scheduler. So here you can see every time the scheduler finds a VM. In this case, it found 2 pending VMs, and it dispatched the VM to those hosts. And if there is any error with the scheduler, you will see it here. And you have the Sandstone log also. Here you can see all the things that Sandstone is doing. So if there is any problem, you will see it here and you can debug it. And finally, there are logs for one gate and one flow. They are the same as 1D log. You can see everything is happening in those servers. And that's all. And as you can see, there are every day OpenNebula creates a new file with all the logs between those dates. So I think we are going to make the break now before we continue, a 30-minute break, and then we are going to see the users and groups and the Sandstone views. And